Yeah, that's fine.
Okay, cool.
Mm.
All right, cool. So I'm basically recording now since you guys are okay. For those of you who could not be here. So yeah, so again, very quickly, exam 2 p.m. Monday, we will start. You guys join the Zoom link at 2 p.m. I will upload the PDF file of the exam on a sub-module called exam in the content of your D2L, and then you download it. I give you 15 minutes to print it out if you want. Not 15 minutes, 5 minutes to print it out, and then if you want it, if you don't, that's okay. And we will start the exam 1.5 hour. You write it on letter size paper, something that I can read, and then after 1.5 hour, you scan your document, you upload it to Dropbox, and I'll give you 15 minutes to scan your document, your exam, and upload it to Dropbox. Then let's talk about the exam itself. So it kind of have two parts. One part is the questions, I call it, and the questions are basically 10 questions there. It's just true and false. And it's coming from both Drilling Fluid Lab and also from the uh, materials that you have learned in the lecture part. So the Drilling Fluid Lab, I didn't include the last two labs that some of you guys went online and couldn't be there. But I remember all of you were there for the lectures, PowerPoint presentations. So those PowerPoints are available on D2L. There is a lab submodule there, which you can have access to and read through that. So there are some questions coming from there and some questions, it's just 10 questions, true and false. So you just select which one is true, which statement is not true. So that would be the question part. And then there are 4 problems. And the problems coming from the, you saw the equation list, right? So you would need to be familiar with those parts, which basically hook load the drilling rig calculations, and that includes the hoisting system, right? Let me see if I have the equation sheet here. Open the equation sheet, share my screen with you guys so you guys can see. All right, share my screen. All right, here you go. So this is your equation and data sheet. So several parts here, right? From the drilling cost calculation. You are not allowed to write anything on this equation sheet. You see there are no units. There are some unit conversions though, but I didn't mention any unit for these basically equations. You would need to know what units you would need to use there, right? And also you're not, of course, allowed to use the notes or book or any type of things. It's a closed book exam. So drilling cost, that's the last part of chapter 1. Rig power system, rotary system, hoisting system, circulation system. And for each of these parts, there are at least one example in the slides, right? In addition to your homeworks. So if you're familiar with the way you did your homework or the way the examples are solved there, I don't think you will have problem. Make sure you understand the concept of basically these calculations. What does capacity means? What does, I don't know, pipe annulus displacement, what do they mean? If you need any conversion factor, the conversion factors are here as well, right? So That's one part. Another part is basically the hydrostatic pressure and buoyancy force, which is connected to the axial tension calculation. So axial tension, you saw how we did calculations, right? There are not any specific equation. It's just you know how to calculate the buoyancy force, how to calculate the weight of the casing, and calculate basically the total summation of all those forces at any depths that you want to calculate. But I still put the hydrostatic pressure equation there, the definition of effective weight, and what is the density of the steel. These two are related to each other. So in terms of axial tension, again, if you know how you did your homework, then you should be fine. No problem there. And also rheology. So rheology kind of more related to your drilling lab, right? And how these equations for Newtonian, Bingham plastic, power law, and Herschel-Buckley model. So that's how the rheology. So there are 4 problems. Well, before that, do you have any questions from the equation sheet?
There won't be anything asked of us that's not on the equation sheet, correct?
Correct, except the axial tension, which still you use the same equations here, right? I mean, but other than axial tension, which it's basically based on the pressure hydrostatic buoyancy calculations, the rest, you will not need any other equations. Everything you need is here in this equation sheet. Any other questions? Nope. All right. So, well, rheology, you will have a question from the rheology, I'm telling you. So make sure you understand these equations and how you calculate basically different properties. So there is a problem there for you to calculate the rheology of the fluids. Of course, the cost per feet is important, right? We did do examples, you did homework. We did also do an example in the synchronous session, right, on drilling cost calculations. And just make sure you understand this equation very well. You understand the rate of penetration is how much depth you drill with divided by rotating time. And that's all you need to know. If you understand this equation, you can solve any problem for drilling cost. And we did also do one synchronous session problem. I think I recorded that one too. It should be there in the D2L. So axial tension, I mentioned, right? You will see a problem from axial tension as well. And there is one more problem which is related to drilling rig. So I'm not going to tell you which system that is, but there is one also problem from the drilling rig system. So that's overall, that makes the 4 problems of your exam, okay? And then there are again 10 questions that you need to answer true or false, and that's all you have for the exam. Do you have any questions? So if you're familiar with the synchronous session problems, homeworks, examples, you should be fine for the problem part. For the question part, you don't need to read the whole book, of course. Just make sure you look at the slides for drilling mod and look at, there are no problem solving from the drilling mod, from the drilling fluid lab. So you don't need to solve any problem coming from the drilling lab. It's just the concept of the drilling lab that is part of the questions. And some, overall concepts that we discussed in the slides for the lecture part. So that makes the whole, basically, lab, the whole exam. It's 100 points. It's point-based exam, right? And if you look at your syllabus, you see there are 3. We are trying to have 3 exams. And those 3 exams, the first 2 exams at least, are not comprehensive. So once this exam finished, next exam will be focused on the new material that you will learn. And we will talk about the final exam later to see how we want to do it. It's too early. And this semester actually is also very hard for you guys as well, since everything is online. So if you remember from RAC Fluid, we have the final exam to be kind of comprehensive, but maybe this time we don't do it comprehensive. We just have it as the whatever part that we discussed, new materials coming from new materials. And your full basically grade will be calculated based on accumulation of all these points from these 3 exams. So yeah, I guess that's it. So if you guys don't have any questions from the exam and how the structure is, I'm here to answer the questions that you have from the materials that you have studied or you didn't understand. I can talk about that. Any questions from anything?
Should we read the book just to be sure we're prepared? I mean, I've already read the book, but I want to. What chapter should I read up to 2?
Right. Yeah. So in terms of understanding, well, if you read the book, that's awesome. Because the book basically discusses all these things in very good detail and very smoothly. So it helps you a lot in understanding the drilling. However, I should say that if you are familiar with the slides and the problems, the homeworks, you wouldn't need to read the book for the exam. But I definitely encourage reading the book. But, you know, yeah, the questions that I designed are coming mostly from the slides and the homework problems, or, you know, the examples in the slides. Any other questions? Any topic that you guys want me to cover now and tell you if you didn't understand specifically from the problems solvings, or any part that you didn't completely understand it?
Can you go over one of the hoisting system problems?
Sure. The hoisting system. So hoisting system basically are these equations, right? Do you see my whole screen? So if I open PowerPoint, let's see if you guys can see that. Do you guys see the PowerPoint? No? Okay, so I have to stop sharing and share my whole screen. All right, so now you should be able to see. Drilling costs. So hoisting is, I guess, part of the previous slides. Oh, not this one, but this one. All right, so not this one too. Should be, or maybe this one, 2B. Okay, yeah, should be here. So hoisting system is basically the part that is responsible for lowering and raising the drill string, right? And it provides a space on the top for if you want to make connections, if you want to do tripping, it basically provides you a space on the surface that you can work with those, you know, drill string sections, right? But the main duty of the hoisting system is basically provide the means to lower and raise the drill string, right? It has a DRIC substructure system, right? And it has a block and tackle and drawwork, right? So overall, I think I have a picture of that. here, right? So there is a drum, there is a draw work in which the fast line is attached to, right? This is called the fast line, which moves upward and downward. And then this is the crown block, which is static, stationary there. And then there are a number of lines that are attached from the crown block to the traveling block, and traveling block is connected to the drilling hook, and we call it swivel as well, right? And then the swivel basically lower or raise the drill string system, and then there is a deadline, right? This deadline is there, it doesn't move. That's just for emergency purposes. But if you want to do calculations for hoisting system, if you look at this part, that's the main part. That is where we calculate the force on derrick. So there are multiple lines attached there. One of them is fast line, which exerts force, right? There are n number of lines attached from crown block to traveling block, and then there is one deadline. So all these three components exert force on your derrick structure, okay? Now, how do you calculate it? There was a simple example here on basically a pulley system, right? And if there is a weight, 100 pounds, you want to pull it, right? Or just lower it, then this force is 100 pounds. So this should be equal to 100 pounds, just the force balance on this pulley, right? Now, if you have basically this weight attached to two lines, then each of the lines are handling 50 pounds of this 100 pounds, right? And there is a pulley here. So if this is 50, then this will be 50 as well, right? In this case, this 100 pounds is attached to 4. So that's each of them then makes 25. And then since we are pulling this one through this pulley, if this is 25, then this is 25 as well, right? So this was the overall idea. So if the number of lines increases, which is the number of lines here, then you have a better, basically you would need less force to apply, right? But overall, the main equation that you see also in your equation sheet is this equation. This is the derrick force. And the derrick force is calculated based on the weight of whatever drill string is here, and the fast line, the fast line and the deadline force, right? So these three forces makes the whole force on the derrick, right? This is again crown block, right? And this is called traveling block. And the drill string system is attached here, right? To lower or raise. Now for each of these, we found basically the equation, right? The weight is just the weight, whatever weight that is, right? If you have a drill pipe, you have drill collar, whatever you have attached there, that's just the weight, right? And the fast line force is calculated based on W over N, right? Remember, again, this example, this is 100 over number of lines, right? So W over N, that is the fast line force, right? And your fast line is here, actually. This is your fast line, which you are trying to do. So it's a function of number of lines that are lowering or raising that weight, right? So W over N, but because there are frictions there, right? We consider an efficiency there, right? Efficiency of those basically pulley system that we have there, right? So you need to put the efficiency there, and that efficiency can be calculated using this equation. And in this equation, E is called individual sheave efficiency, which is usually considered to be 0.98, and N is the number of lines. So for example, if you have 8 lines, then this efficiency is 0.851, right? And that comes into this equation, okay? And then there is a deadline, and deadline is just W over N, same as fast line, but since deadline doesn't move, there is no efficiency here, right? So efficiency is 1, basically. So if you basically factor out W, make a common denominator, you end up to having this equation. This is called the derrick load, right? Any questions so far?
Are we going to be giving those efficiencies?
Well, in the equation sheet, there is that. No, it's here. In the equation sheet, this is that equation, right? You see here, E is equal to e to the power of n. If this lowercase e is not given to you, just consider to be 0.98. And if basically, I may give you a table, or I may give you, if I may not give you a table. So you just know that how to use this equation to calculate the efficiency, right?
Okay.
And it's just 0.98 to the power of n. That's it, right? That's going to give you the efficiency. Any other questions? All right, so well, this was the example, right? We had a rig which must hoist a load of 300,000 pound force, right? The drawbar can provide an input power to the block and tackle system as high as 500 horsepower. 8 lines are strung between the crown block and traveling block. Calculate the static tension in the fast line when upward motion is impending. So this is W, right? The weight of your system there, right? And the horsepower is given to you 500, so that's P, right? And this is overall horsepower, right? This should be adjusted based on the efficiency of your rig system. And this is number of lines, that's N, right, in that equation. And that's it. Now, a question for you guys. This is the case where your wellbore is empty. It's just drill string there. How about if you have a drilling fluid, which is 13 pounds per gallon inside the wellbore? Then how do you consider calculating the load on derrick? Does it change anything?
Yeah, because there would be a hydrostatic force, right?
Yeah, that's basic buoyancy, right? So buoyancy will change your weight, right? Buoyancy will change the effective weight. How? By using this equation. When you have drilling fluid in the system, then your weight is not W anymore. It's effective weight. If the density of fluid is 0, which means that you don't have anything inside, then WE is equal to W, so that's it. If you have a drilling fluid of 13 pounds per gallon, then the weight that you use for the load on the derrick should be the effective weight and not this weight, because you don't feel the actual weight of the drill string if you have a fluid inside your system, inside the drill, inside the wellbore, right? So in that case, if there was a drilling fluid here, then you would need to calculate WE, which is W multiplied by 1 minus density of fluid over density of steel, which is 65.5. This is pound per gallon. And if this is 13, then you use 13. You calculate this WE. And then in your calculation, instead of this W, you should use WE instead of W. Does it make sense? Because after all, WE is the weight that you are trying to lower or raise, not the W, right? Anyway, just a point for you guys. All right, so the first part is to calculate the static tension in fast line equation. You refer to your equation sheet. FF is the fast line, W over EN. So W is 300,000. Efficiency, in this case, there are 8 lines. If you calculate 0.98 to the power of 8, you would get 0.84. You should get 0.84, basically. So that efficiency is coming from there. Or if you had access to the table you would do that. Actually, you would get 851, which is okay, this number to use. That's fine. It's a bit different because the tables in the book are not exactly calculated based on 98% sheave efficiency. Anyway, so number of lines, 8. So you calculate the force on the fast line. Make sense? So next part is, any questions? This for part 1? No? Well, part 2, maximum hook horsepower. So you have 500 horsepower, you need to multiply it by efficiency, and then you have 420.5. So this is the effective horsepower that you have in hand available. Your engine provides 500, but because there are frictions, you will only receive 420.5 maximum, right? So that's the horsepower available to you. The actual derrick load. So derrick load, we discussed that, right? So did I skip? Yeah, the maximum hoisting speed. So hoisting speed, again, I think we have the equations in the equation sheet as well. Yes, this is the equation sheet. V is the hoisting speed basically here, right? And PH is the available horsepower, and the weight is the weight that you need to lower or raise. So 420.5 was the available horsepower, weight is 300,000. This is in pound force, this is in horsepower. Again, you go to your equation sheet, you need to convert horsepower to feet pound force per minute, which is this one, 33,000, right? This actually came in the rig power system, but still, that's the conversion factor which is there. So you do that and you get the speed, that's it, right? Equivalent derrick load, equivalent, well, the actual derrick load first, which is that equation that, again, you refer to your equation sheet, and well, it's here, right? So you would need to substitute W over En here and W over N here, and that's it, right? And that's the same equation as this one, right? So you put the numbers in, it's just substitution of numbers. If you know what FD is, then the equation is there, you just directly go and use it, right? So that's the actual, and then we define the maximum derrick load because the forces on each leg of the derrick is not the same, right? They are not the same forces. So if one of them fails, the whole derrick will fail. And the maximum that you can put is calculated based on this equation, which is based on calculations on leg A, if you look at the book. Again, simple 8 lines, right? And multiplied by the weight that you have, that's 450,000 pound force. That's the maximum you can put, okay? Now the ratio of the actual derrick load and the maximum derrick load is gonna give you the derrick efficiency, which is 84.9%, okay? And I think that equation is here as well. Yeah, you see all the equations that you would need to solve that problem is here. The only side point that I mentioned was that if you have a drilling fluid, then you would need to use effective weight, right? Because the effective weight is what you feel in terms of moving the drill string system up and down. So any questions? Any questions from any other part that you guys didn't understand? Nope. All right, so if you guys don't have any question, that's okay. Please study for the exam, and I'll be in my office hours again tomorrow from 10:45 to 12. as well as on Friday. So if you guys have questions, you can send me an email or come to the office hours and we can discuss any problem that you might have. Sounds good?
Thank you, Dr. Mo.
Yeah, no problem. Have a good day, guys.
Yeah, you too.
Thanks.
Thanks.
Thanks. See ya.
See you. Bye.